You've heard a lot about this program, and the first driving aspect of it was FMVSS 126. And that was what motivated SEMA to get involved in this whole area. However, this program has also led to the ability to have a lot more capabilities for SEMA members. The basis of the approach was to try to provide SEMA members access to both the tools and technologies used by the OEMs and Tier 1 suppliers. With that, we've developed techniques that go way beyond demonstrating 126 compliance. And to date, the focus has been on 126 compliance. But as you're going to hear today, there's really a lot more capabilities that are available to you. And as you invest in demonstrating your compliance with 126, for a very little bit more, you get a lot more capability. But you'll hear about that from the following speakers. But what I'm going to discuss is the capabilities that we've used to date and developed to date. This is a vehicle running a 126 test. Now, you'll notice that is certainly a vehicle that is way beyond 10,000 pounds. And the reason I chose to show that particular one is, besides illustrating the test, the reason that vehicle is being tested is because it was part of a bid for a government contract, and the government was requiring for that vehicle to pass the 126 requirements. So even though the letter of the law doesn't state it, they force that into the bid. Now, when you're doing third-party physical testing, there's some things that are required for it. First of all, of course, you need the modified vehicle and a test track and instrumentation. And that instrumentation is fairly extensive. You also notice that one has preventive rails on it so that the vehicle can't roll over, which is typical of any high CG vehicle. Now, the pros of doing this is that it's a very efficient approach, and you get comprehensive data from it. However, the cons for that are that it's a very specific test. You have that vehicle and its configuration. That's the one you're getting the data on. With that, you have limited data for any performance issues that you may end up encountering, unless you've added extra instrumentation beyond the 126 test. Now, with all these slides, I'm going to show you the recent quoted costs or estimated costs. They're a range. They only should be used as guidelines, and is when you would set up a specific program, then we'd be able to, you would get exact costs from the various SEMA supplier companies. Another solution that's been used, in fact, Tim Watt's company was the first aftermarket company to be using it, was HardwareInTheLoop. And this is one that provides you with a lot of capabilities. First of all, you are required to get a certain amount of data for the simulations that are used. And modified vehicle characteristics are critical. Most common is kinematics and compliance data, which you're going to hear about from Bob Simons, and then also tire data. So those are probably the two main ones, but those are data that you have to acquire. Now, the pro of this approach is that you get extensive data and analysis not only of 126, but any other type of standard test you would want to run. And beyond that, your hardware can be, variations can be evaluated extremely quickly. Now, the cons are that it requires access to the data buses that are on the vehicle. Depending on the OEM, they may be a cooperative, or it may be something you have to spend some time in getting. Depending on where you do the testing, you may need to rent a garage space. But there are no physical tests that you would run yourself with this. Now, you'll notice with the quotes there's a wide range. And the one thing about an HIL test is that the initial setup is a bit complicated and takes some time. But once it's set up, you can do variations of the vehicle very, very quickly. So say if you were testing, you have a Ford F-150 package that you want to offer. Well, SEMA already has the baseline data for the Ford F-150, and anybody participating in this program gets access to that. If you do need to get a characterization of your particular system, so that would mean there would be some involvement there, some costs there. But at the same time, once there's a setup, you don't need the modified vehicle to be physically there. You're using the electronics and the brake systems that are on the modified vehicle, but it doesn't need to have the lift kit on it, for example. So now you can take one Ford F-150, and if we could coordinate with a number of companies, you would be able to have company A come in, test with their characteristics, very quickly transfer over to company B, test with their characteristics, and then company C. And in so doing that, each one has their own data, it's all confidentiality is maintained, and you end up with what you needed at a lower cost, and you'd be able to explore much more than just 126 with your vehicle. And you'll hear more about that. One other technique we've been working on is pure simulation and analysis. And with that, everything is done in just software, but again, you need the modified vehicle characteristics. You still need your K&C data and your tire data. Now, the other thing you have to have some confidence in are generic system modules. So, every company that offers ESC, I'm talking about OEMs, uses it to brand with it. So they take very much pride in the way they've put the vehicle together with the ESC system. So you would have to have some idea about the subtle differences between them. But on the other hand, if you're just focusing on 126, the characteristics there are very similar from OEM to OEM. And in that case, the generic models that we're able to develop should function quite well for you. Again, this is potentially the best value option. You do get a wealth of data, just as with HIL, and it definitely minimizes the time and cost, and is a very flexible approach. However, we have not fully validated that approach within the vehicle dynamics program, but yet this is a very common technique used by the OEMs and Tier 1s. The other thing is, again, the accuracy of what we're doing is really dependent on our generic models. But as you can see, it also has very reasonable costs. Another technique that we've been working with is doing third-party performance evaluations of a vehicle. Now, in this case, you don't do a formal 126 test, so you don't have the prep work required, but you do run through standard tests that are used to determine understeer and other characteristics of the vehicle. The pros of this is, again, you get extensive data available for analysis, and that the hardware variations can be evaluated quickly. You can put your new shocks on, you can do whatever, all as part of the test setup. Now, the cons is that this really is one step away from a formal test. When it comes to evaluating 126, you're relying on your analysis saying, okay, we meet these key characteristics of the vehicle that has passed, and now we'll be able to extrapolate that we would pass the test as well. And it may require a facility rental, not necessarily a formal test track, but you're going to need some space to do this. And again, those are recently quoted costs. Another technique is a comparative analysis. And in this, you take advantage of the database that SEMA has put together so far. Right now, the best example of that is the Ford F-150. Starting with Tim's vehicle, and then since then we've had several other companies that have tested their vehicles. So we have a wealth of data on the Ford F-150. And you still need your modified vehicle characteristics and the baseline vehicle characteristics. But again, the baseline vehicle characteristics are from the SEMA database shared across all the participants in the program. And then we will sort of look at the characteristics of other modified vehicles to establish the range of acceptable variation in the key characteristics of the vehicle in order to pass 126. Again, this is a high-value option. It takes advantage of the Vehicle Dynamics Program database, and it focuses on a specific dynamics characteristic. Now, in the case of ESC, we believe that understeer is a very key characteristic that the OEM strives to achieve with the vehicle and maintain with ESC. So then we evaluate through this process the the changes that have been made to the understeer characteristic by looking at key aspects of the KNC data. And with that, we've been able to successfully extrapolate that a vehicle would pass 126. And again, this becomes a very cost-effective method of doing things, but you are dependent on the quality of the analytic methods that are used. So those of you who've been attending this for a while have seen this slide many times. And as you look at it, you may say, well, you just showed me data where physical testing was actually cheaper than HIL. And that is true. And when we started this program, physical testing was more expensive than HIL. The initial costs at that time for the first company were well into the $40,000 range. But the thing is, if you do the same scope, evaluate these techniques within the same scope, use all the capabilities of HIL, to run all those physical tests would cost you more than the HIL setup. And then, of course, we have the pure simulation, and we've gotten more and more improvement in what we believe is the accuracy of what we're doing and how to apply that for what we're investigating. And in terms of HIL, the cost has come down some, and in particular, if you're able to set up a program where we leverage several companies, the cost comes down significantly. So I've been talking about what we have done, but we're going to have these gentlemen from various companies that are supplying the services that are used in this program. Now, you don't have to employ every one of these companies in doing this program, and that's why I said the first step is to set up specifically what your project is and what you want to achieve. And between myself and CU ICAR, that's a good place to start. We can talk about options that way. So you'll hear from Terry Ledwidge of Link Engineering about the third-party testing, and then Bob Simons from Morse Measurements about the KNC testing, Dr. Tom Gillespie from Vehicle Dynamics Simulation. And in all these cases, we are talking about more than just the application of 126, but where these various services could take you and you be used in overall engineering. Santosh Jogi will talk about HardwareInTheLoop from DSpace. Rich Darling from Altair will talk about engineering with simulation, really using these type of techniques to be a part of your development program. And then we'll finish with Mandar Hazar, who is going to discuss the CU ICAR's role in all this, which is a greatly expanding role.